Okay, we're going to skip over section 4.4 and 4.5, but we'll come back to them in another day. And we're going to do 4.6, which talks about isosceles and equilateral triangles. And you already know what these are, so it's not going to be anything too like earth-shattering that we're going to talk about. But it's some things that you need to know really well and be able to use in our proof. So there's going to be 1, 2, 3 theorems and one little just random fact. So the first theorem is called the isosceles triangle theorem. And it says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And like always, we're going to draw a little picture of kind of a visual representation of what that means. So if we have a triangle that has two sides congruent to each other, that's an isosceles triangle. That means that in that same triangle, it has two angles that are congruent to each other. And the angles are always opposite of the sides. So those are the base angles of the isosceles triangle. You already know that, but here is the theorem and the way that you say it when you're doing a proof. Now, this next one is going to be almost the exact same thing, except it's going to be the converse of the isosceles triangles theorem. Okay, so it's the converse, the isosceles triangle theorem. And if you remember what converse means, it means we're going to take the P and the Q, we're going to flip them and write it in the opposite order. So we say if two angles of a triangle are congruent, then the sides opposite those angles are congruent. And I know this is kind of common sense, but it's only because we've been talking about it for a while and you're comfortable with it. So don't take it for granted when you're doing a proof that you can just say like, oh, well, that's obviously true. You want to be able to back it up with the reason, and the reason is either the isosceles triangle theorem or the converse. So remember, converse says that if the two angles are congruent, then the sides opposite of them are congruent. So the theorem says sides are congruent, then the angles are congruent. The converse says the angles are congruent, then the sides are congruent. It's a small detail, but if you're really understanding proofs and trying to get better at it, it's an important detail. All right, one quick little fact that we're going to write down. It's not related to these two theorems. It's just a fact. Is that the angle bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. Okay, we're going to draw a little picture of this too, so it makes more sense. So we have an isosceles triangle. So that means it's going to look like this. Now, our statement said that the angle bisector of the vertex angle, well, that's this angle. So if we take that angle and we split it in half, that means this angle is congruent to this angle. That's what an angle bisector does, right? The angle bisector of the vertex angle is perpendicular to the base at its midpoint. So that means this is a 90-degree angle, and it splits the base into two equal parts. Okay, all of that is talking about the height. So this blue dotted line is the height of this triangle. Only when it's an isosceles triangle, it splits the base into two equal parts at the midpoint. It's perpendicular to the base at the midpoint, and it bisects the vertex angle into two congruent angles. So when you read a problem and it talks about the height of an isosceles triangle, that's actually telling you a whole lot of information. All right, one more theorem and we are done. Actually, it's like 1.5 theorems. It's two little things we're going to write down. These are two properties. We talked about isosceles. Now we're going to talk about equilateral. So properties of equilateral triangles. Okay, remember equilateral means all three sides are the same. So these are going to be not necessarily related to the isosceles ones we just did. Okay, so the first one is that an equilateral triangle is also equiangular. Okay, so we draw a little picture of that. Equilateral triangle means that all the angles are the same. Well, vice versa from that, or the converse of that, is that an equiangular triangle is also equilateral. And I know that you already know this. Okay, this isn't rocket science, but it's important that we write these things down because if we want to use them in our proofs, we want to know how to say them. We can't just say, well, look at it. It looks like it's the same, right? I'll write that down. So one more I forgot. We actually got three. So you can scream at me tomorrow. An equilateral triangle and actually we'll say an equilateral or equiangular, right, because they're the same thing, has three 60-degree angles. So if we have this equilateral triangle, how do I know it's equilateral? It's because it's marked with the three little marks. Otherwise, I don't know that. I can't just assume it. We can say in this picture that the measure of angle A equals the measure of angle B is equal to the measure of angle C, which equals 60 degrees. And what this would lead us to is a lot of substitution in a proof, right? Because if we needed something about angle A, but we knew something about angle B, well, we could just substitute them, and we could substitute the 60 degrees and all kinds of substituting. So that's it. Isosceles and equilateral triangles. See you tomorrow.